Go ahead.
Okay, everybody, it's March 15th, 2023. I'm Gary Bergcross, co-chair of this session and also co-chair of the summit, which the topic of this year's summit 2023 is helping scientific researchers better use ontologies. We're talking about tools, methods, and best practices. I'll introduce our speaker shortly, but before I do that, I wanted to just mention that next week's session, which we're normally on Wednesday at noon, we have an additional session preceding it. The topic is Wikidata, and it turns out that the Obo Foundry folks are having a session on Wikidata, and so at 11 o'clock on Tuesday, and so we're going to sort of leverage that. There will be information on our site on how to do that, and I'll also post a link into our chat here. So with that, let me introduce our speaker today, who will be speaking about applied ontology engineering and the missing pieces. Our speaker is, and we're very happy to have him, Karl Hammar, who has a PhD from Linköping University and had for a number of years headed the Department of Computing at Jönköping University in Sweden. Dr. Hammar's research has focused on methods and tools, which goes with our theme this year, supporting ontology engineering in scenarios ranging from as widely from building automation to veterinary syndromic surveillance. Among his well-known papers is engineering ontologies with Patton, the extreme design methodology, authored with Ivar Blomqvist and Valenta Presutti, and it appeared in the journal Ontological Engineering with Ontology Design Patterns in 2016. Another is How to Document Ontology Design Patterns in 2017 with Nazifa Karima and Pascal Hitzler. It was in the Journal of Advances in Ontology Design and Patterns. His most recent and notable research and development work targets the smart buildings domain, where he, among others, co-founded the Real Estate Core Ontology and Consortium, a leading edge technology in the commercial real estate vertical, and the recommended solutions for use with the Azure Digital Twin platform. He's now a senior technical program manager at Microsoft, where he works on building industry-specific cloud solutions. And with that, let me turn it over to Karl.
Thank you very much. And those nice that you found those articles. Most of them are actually from proceedings volumes, not journals. But yeah, that they've been cited a little bit and reflect a little bit on what I've done. So to kick it off, I was asked some time ago to give this talk, and it is, I'll be full disclaimer here, it is a redo of a previous talk that I've given on this topic, which I still think has some value. But if you were at the workshop on ontology design and patterns at the International Semantic Web Conference last year, you will have seen these slides. So just for full disclosure there. So let's see. About myself, well, it's already been discussed a little bit, but what I worked on include a lot of things that touch upon commercial uptake or industrial uptake and adoption of semantic web technologies. I think it's also important to mention early on, though the company name that I work at, Microsoft, was mentioned, important also with a disclaimer that in this case, I'm speaking in my private capacity. I will be mentioning company. So that's also PowerPoint templates and so forth. Third and final community needs to go. Well, so bear that in mind. So going back to the very fundamentals, why do we do ontology in the first place. This framing is something that I bring up with students and colleagues. And I think it's important sometimes to think on this, because it is easy, if you are an ontologist and you have been an ontologist for some time, to get stuck in ontology for ontology's sake. And my take on it is that we are doing ontology, or at least I am doing ontology, to add functionality to some system. Most often that system is a software system. Broadly speaking, I'd say there are two main drivers for why that good stuff that comes with inferences and that bit. And the other is the rather more simplistic data integration challenge, though that also comes with its difficulties. Now, I would note here that this is a very sort of functionality oriented. There are valuable intellectual pursuits in understanding the world. And there we're bordering on the philosophy side of take on it. And brilliant technology in and of itself. This is a typical this comes hard. Some rational oriented, sort of rationally designed process over time, using some sort of structure to do your hard work. And if you resolve, publish it, and great success follows. Of course, there's back and forth in this, and 2 steps forward, 1 step back, etc. But generally speaking, it is the idea that or the value that is derived would very often derive from the value of a correlation between the work, right? And in industry, that's also the case, hopefully, but I find it to be somewhat more stochastic, somewhat more dependent on perceptions and other immeasurables. What do people think of the technology? And what wins out in the marketplace is not always necessarily the best technology. There are many factors that go into it, business models, etc. And the latter I found personally, and I think also among colleagues, to be a bit difficult to wrap your head around when you're to these companies and is adopted and taken up. So I still think the latter is important, though, to have that impact, to have that adoption. It affords you evaluation opportunities in the real world, so you can actually go out to technologies. If you get adoption of these technologies, you can actually go out and test how well is that working for real, not just with your lab of master students or what have you. Typically these days, funding is contingent on actually users. Real world outside of sort of the somewhat ivory tower scientific community. And it's also a lot of fun to meet people outside of your normal context. So to me, this is all very worthy pursuit. So going into then, what do we need in order to get that adoption of semantic technologies? And this is my slide on developer experience, or DevX. And I like to bring a caveat here, or just mention that I'm not a DevX expert by any means at all. There are developer advocates whose entire careers are this area. So this is my take on it from brief immersion. So there's a saying that culture trumps strategy. You may have heard it. I'm sure you've heard of it. And in successful tech institutions, whether they be the company I'm at now or other IT businesses or successful academic tech institutions, there tends to be a dev style culture in place where devs, software developers, do affect and often decide on technology choices, not necessarily in the big strategy document sense of the word, but rather through establishing culture, establishing what works, and you get this percolation upwards from developers through whatever management stack you may have, depending on what works to solve the problems that you have. And some key criteria then of technologies that are important to developers in this choice are listed in the orange boxes here. So first run impression, obviously, the first time you pick up a piece of technology, a tool, software, an API, what have you, SDK, how easy is this to just pick up and run with? First run impression is hugely important. Second, the easy wins or first time to first success. So once I picked it up, I played around with it, and now I want to achieve something. I want to reach my first value. How long time does that take? How complicated is it? Third, explorability. If I now want to go and do something that's not, listed on the box, I want to go and attempt something new, something more complicated. How easy is it to explore the documentation, to explore the API of the software in question, to explore the functionalities, et cetera, to go beyond. Fourth, reasonable defaults. You may have heard of convention over configuration. So typically we want, oh, there's some background noise there. Could someone mute that, please? So typically we want the software to be configured in a way, or the tool to be configured in a way that it by default allows us to do what we want to do. And then if you want to do something that's less common, then you'll configure it separately for that. And last on my list is the evolution trajectory. Where is this technology headed? Even though it might not be perfect for my use right now, it may be very clearly driven by people that are pushing it in a direction that makes it, that grows trust, basically. So I bring this up because I think that the semantic web ontology community, or ontology community in a broader sense, perhaps, has challenges in pretty much all of these things. And I'll try to get into that now. So a subset of my grievances with semantic web ontology technologies. And I'll go into each of these in more detail in the subsequent slides. But to begin with, the very foundational bit, basic node edge node modeling. We have ambiguity in what we mean by a node edge node construct. And that is really unfortunate. And I'll again detail this later on. Overuse of global fields and global semantics that come along with it. Typically, your modeling in most cases will be type-based modeling in most real-world cases, and there you would have local semantics, and I'll get back into that as well. Statement contextualization. This is the property graph thing. We want to be able to assert statements about relationships, typically. That's a really common scenario. We have some tooling insufficiencies. I'll specify what I mean by that. And then we have the reusability, where design patterns and foundational ontologies come in, where there's promising work, but there's also a lot to be done. And I'll detail these starting now. So node edge node modeling. On the screen right here, we have a very simple structure. Person owns car. Could be building located in place, or could be anything really, where you have a node edge node construct. And that comes up again and again and again when you're whiteboarding your data models. And then you try to formalize that into OWL or shackle, and you'll find that there are in OWL at least 2 ways of representing this, and in shackle at least 2 ways of representing this, all of which have some semantic difference. And I think that's a problem. I realize that if you are in the knowledge modeling side of the fence, the sense of the fence, the side of the fence for ontology for the sake of so shall we say, deep formal ontology and representation of knowledge, then this does matter and it is important. If, however, like me, you are more on the data modeling or data integration side of the fence, then this is a problem. So on the left-hand side, OWL, of course, owns can be defined as an object property with domain and range in RDFS, or it could be defined based on restrictions and subclass and equivalent class assertions in the OWL way. And in shackle, you have that you would somewhat easier. The person would be a node shape. The owns would be a property shape. But then the question is, what is car? Is car SH node or SH class? And there is a difference, of course, between these two in shackle. If I recall correctly, SH class implies that there is an RDF type relationship somewhere, and SH node simply implies that there is another property, another node shape car that you need to adhere to. So subtle differences. And I'm telling you, the developer most often does not care about the subtle differences in the last case, probably not in the former either. And if I sit down and explain this to a developer, a colleague, how long time is that going to take to explain this distinction? Depending on how my pedagogical ability, 10, 15 minutes or something, to describe the very fundamentals, the very fundamental 2 nodes and 1 edge on screen. That is not great. And when we look at how our tools available, your protege or your top-rate composer or whatnot, how they handle this, I'd say they don't handle it at all, because they're operating on the OWL or shackle level, not necessarily the level that we want to prototype our ontologies on and to do our knowledge elicitation on. So this is not a great first run experience. This is one example of several where there is ambiguity, but I think it's the most obvious one. Global field semantics. Why is this bad? So again, person, simple relationship to some other node. In this case, it's a string. It could be another IRI, doesn't matter. Family name here in RDF is given using the example colon family name IRI here in this example, which is a globally defined IRI. Now, in the large majority of modeling cases, I don't necessarily need to talk about family name in a global sense and global semantics. And I'll, on my next slide, describe why global field semantics are bad. But most often, I'm looking at family name in the context of a person. That is the context in which it is relevant. It is not necessarily globally relevant. Why do I mean this is a problem? Well, because you get name collisions easily with these very common words that are somewhat ambiguous, things like name or time or member or what have you. So the name of a company is quite different than the name of a person, or the name of a substance or the name of a place. And unless you want to go with extremely vague and very, very generic definitions, then you can't really capture that if you are defining name in a global place. And sometimes it becomes even trickier when you want to talk about like specializing these for particular purposes. So membership and parthood, typically, you want to be able to have the very generic name has part or is part of or has member or is member of whatever. But you want them to mean different things in different contexts. So parthood in organizational context implies that organizations are parts of other organizations, or people are parts of organizations. whereas parthood, of course, in mechanical industry implies that only equipment is part of other equipment, or places in geography are part of other places. And so you will want to apply local constraints on a globally defined name. Yeah, so of course you could just define your names globally and then define all your semantics locally. But then what is the point of the name globally defined in the first place? So this is a confusion and a problem, and you come across it many times, and especially when you're dealing with transmitting data across other systems that are object-oriented in nature, and where fields very typically belong with the classes on which they are defined, rather than globally. Then we have the statement level metadata. This is a bit of a dead horse, of course, but it needs to be beaten anyway. We have very commonly the need to express relationships or properties about relationships. In the case on the screen right now, it's from the smart building space, where you have your pump that feeds the cooling circuit. And I need to be able to say, what is this pump feeding to the cooling circuit? Is it water, or is it some coolant substance, or is it, I don't know, air? That's unlikely, I guess, but and other common scenarios are, you have an assignment of some person to do something, and that may be time indexed or time bounded and so forth, and you want to express those time bounds on the relationship. And in some cases, we can reify this in a somewhat natural sense. So the latter example that I gave there with someone doing something, well, you would typically smack in a role there and say that there's a role concept that goes here, and that role is of a certain person for a certain thing during a certain time, and that's okay. In other cases, such as this feeds relationship, there is no really natural way of expressing that makes sense to our domain users. And there's a bunch of hacks around this. Of course, we have the RDF reification vocabulary, which blows up your number of statements by a factor of 4 or something. Singleton properties and property individual punning is one approach in OWL. You have, can abuse the subproperty hierarchy somewhat. You could say that feeds has subproperties for feeds air and feeds water and feeds gas and what have you in this example, and have that be sort of implicit there. Or you might even, using quads, use named graphs and use the fourth field for some sort of metadata. That's one approach as well. We have RDF star coming along, as I understand nicely, which is supposed to be, it is essentially the quads solution, but on steroids. So to be able to say that the subject or the object position of an RDF triple can itself be a triple. Very promising stuff. I'm not sure whether it's standardized yet. When last I checked, it wasn't, but that was several months ago. I'm unsure as to how long it'll take for RDF star to be integrated into the ontology level that we're operating on, and from there on into the tooling that we are using. So that's a promising approach, but we need it sooner. We need it now. Let's see. And then we have the tooling challenges here. And there's a bunch of great tools out there for ontologies. IDEs, we have Protege, we have Top-Rate Composer, we have several other things. Visualizations, both of the models and of the data, documentation generation tooling and browsing tooling, triple stores, etc. All of this is things we have, or most of it anyway. But it exists in a bit by bit, non-integrated, piecemeal kind of way. In the few cases where it is more integrated, I think Top-Rate is one example where there are more integrated offerings. They are commercial products that cost quite a lot of money. And that's entirely fine, of course. That's not a problem. It's an open market, and these products need to make a living for sure. But what I'm suggesting is that they tend to be out of the reach of hobbyists and or junior academics, or really academics at all without substantial funding, substantial grants. And so I think the community here might take some time to think on whether we can integrate what we have in a better way. And when I put these tools in the hands of software developers and talk to software developers, some of which have substantial experience, 15, 20 plus years of software engineering at large companies. They're not stupid people. They're very accomplished people at very accomplished institutions. They don't really get all of these tools, and they don't have time to get all of these tools because it takes too long to value creation. And they don't have time to take the master level course in ontology engineering tech before they can actually start producing value. That doesn't work. I'm going to be showing you now a tool that I think works really well to cover some of these things, which is not a semantic tool. This is an exemplification. This is actually from a competitor company of mine. So again, I'm not representing Microsoft here, but this is the Neo4j graph tool. I should say my company has great offerings in this space also, but I don't want to bias the talk too much. Now, Neo4j obviously has very limited schema support compared to everything we're used to in OWL and Shackle and RDF, and that's not really my point. My point is that what you're looking at right now includes a visualization, it includes a query language, it includes, if I go to the next slide, some schematization and a data import wizard that allows me to align my data to that schematization. And it took me 90 seconds to start this. That is the developer experience that I talk about when I talk about first run experience. I went to Neo4j website, clicked through their portal, filled in a couple of fields, and boom, this is what I get. And everything is nicely integrated into a nice and coherent interface. Again, my company does similar things also, and several other companies do. Something like this for the ontology engineering community, where you have your data integrated with your knowledge graphs, where it is holistic, where the workflows work, where it is multi-user, that something like that would, parts of that at least, would drastically reduce the barrier to entry to the use of ontology engineering technologies and tools. So yeah, so things we need, I'd say, the integration of the ontology and the data graph. We typically deal with either or. We're doing our ontology in Protege or TopRay or some other tool, and we're doing our data graph, well, it's in a triple store, and on occasion we'll bring it up through a visualization front end. But most often we'll just visualize the ontology. And if you're doing ontology, again, for the sake of data integration, then to me it makes sense that these live in close proximity tooling-wise. GUI integration, definitely across these different steps. I don't want to copy and paste from one place to another. Same with workflow integration. Don't want to copy and paste files from one place to another, to load up a database here, to export there, and then upload something to GitHub, and then download some package here and there. It needs to be a much nicer, more holistic, consistent integration. And of course, multi-user. And then last of my grievances, before I start trying to address these problems to some degree, I really relate to reuse. And this is where I've done work on ontology design patterns. But there are also, I'd like to bring up these foundational ontologies intended for reuse that I think are also can be valuable. Now, my opinion here is that the reusable components that we have tend to be, in most cases, tend to be either much too large and complex, as that would be your foundational ontologies with huge ontological commitments, or much too small and obvious, and that would be most of your ontology design patterns. So many ontology design patterns being, 2 or 3 classes and a couple of relationships, and that doesn't reach, that doesn't go to the height, if you will, of complexity to actually qualify for value in reuse. A lot of thought may have gone into those 2 or 3 classes, but typically that's over-engineered and overworked for 2 or 3 things, right? I think there are some examples that strike to me the right balance there in terms of size. And mind you, I'm not talking about that these aren't, things necessarily you can just drop in and go, or that your quality that's in line with your quality requirements or what your domain requirements are. But just in terms of size, I would say that the analysis patterns in Martin Fowler's book by that same name are an appropriate size. Non-trivially sized, well thought through, yet you can explain them in a couple of pages of text, and they don't commit to everything. The building topology ontology from the smart building space, these days shepherded by the W3C linked building data community group. It's essentially a Russian nesting dolls type approach to spatial topology in smart buildings. But it's really lightweight and has enough of the spatial model to make it useful, but not enough to overcommit to anything. And FOF, friend of a friend, grand old man in ontologies, a sufficient size to cover most of the common use cases, but not too large. I think also in terms of reuse, I think it is important to drive home that the importance bit is not necessarily the serialization into RDF or Shackle or OWL or whatnot, but rather the conceptual solution that we're providing. So, and this is something where I've changed on. I originally thought that it was much more important to have a rigid, formally expressed semantic model. That is important for many use cases, but if the purpose is to provide clarity on how to build your models and how to build your models in such a way that you reuse rather than reinvent the wheel all the time, that you standardize against good practices, then the conceptual modeling bit is a much more difficult thing to handle later on if you get it wrong than simple serialization translation, obviously. So at the end of the day, serialization doesn't matter so much. And so design patterns ideally should be expressible in such a way in any language, basically. They should be expressible in a more generic representation using diagrams or what have you. So addressing these problems, I'll be exemplifying a little bit by using something that we developed at Microsoft. I myself was not involved in the development of this, the digital twin definition language, which I think strikes a nice balance between these concerns. And again, I'm not here to pitch Microsoft technologies, and I'm not saying that you should all go out and do this thing. It's just an exemplification of something I think strikes the right balance, and there are other languages that work well in this space. So the digital twin definition language, DTDL, it's being open sourced, I believe. It was developed as part of the Microsoft's IoT offerings, and the idea is to model things like sensors and whatnot, and digital twins, as obvious from the name. It is JSON LD based. It uses URNs for identifiers, as you'll see at the ID at the top left there, as opposed to URIs. So, and basically it means we don't have a protocol specifier at the front, and not necessarily a DNS name either, which means it isn't, the IDs aren't globally dereferenceable. That's perhaps, perhaps a requirement for you or perhaps not. And I'll go over the basic building blocks. This is just, and return to this to exemplify the building blocks. But this on the screen here basically describes that we have a room on the left-hand side, which on it, there is a property called occupied, which is a Boolean. And on the right-hand side, we have that the conference room is a subclass of room, which has the property capacity, which is an integer, and a relationship booking responsible to a person. These are the fundamental building blocks of that language right now that I'm showing on the screen. We have interfaces. Interfaces are, you can think of them as classes or concepts in ontology modeling. Again, we go back to the digital twin and the IoT space, where interface was supposed to represent sort of your digital interface to your IoT equipment originally. If this were created in you today, it might be called something different, but it's called interface. Interfaces extend other interfaces, so that may create your subclass hierarchy. And within your interfaces, you have a bunch of contents, and these contents can be of 5 types here. And for now, we're going to be leaving telemetry and command out of it because they are very IoT specific and not really relevant to this context. And look at property, relationship, and component. And property that's basically your data type properties in OWL. That would be something that carries your value. And they have schemas which can be primitives, Booleans or integers or floats or whatnot, or complex enumerations, maps, and other objects. You then have your relationships a bit further down, and relationships connect one interface or an instance of one interface to another. So they target another interface. That would be your object properties if you're talking about OWL. So that would be your edges in between nodes or between identity carrying nodes in your knowledge graph, whereas your properties would be your edges to data value nodes. And then towards the end, we also have their components. And the idea is that components allow you to reuse previous definition of an interface inside another. So it's essentially a copy by value integration of one interface into another. And that's quite useful in many cases. So going back here then to this example, obviously here there's only one way of expressing the node edge node construct in this language. That would be the relationship. So going back here, your interface would have on it a relationship, and that relationship would have as target another interface. And that's what we're looking at here. The interface conference room on the right-hand side of the screen has a contents block in which there is another relationship called booking responsible, which targets persons. That's it. No ambiguity there. Your contents also include a capacity, how many people can be in this conference room. And that's a locally defined field. Capacity only has value or only has meaning inside of the conference room. It's not globally defined. So that solves the local field challenge. And then if we go back to this, we'll see also that we have this notion of properties. They can be attached not only to interfaces, but they can actually be attached, as indicated here, to relationships. So this allows us to have the property graphism that I mentioned earlier. So I could have, and I don't have it right now, but on the relationship booking responsible here on this screen, there could actually be a sub property here indicating, for instance, the time that some person is the booking responsible for. So I'm not proposing again that you go and drop everything and run DTDL. There are other languages that are similarly defined. I think if you look at the Web of Things group, the things description language, it's not too dissimilar from this. Again, it's an IoT based thing. I'm sure there are other languages in other domains that attempt the same thing. What I'm getting at is this level of features, this level of semantics is sufficient for a great many use cases and avoids many of the ambiguities and complexities of the ontology engineering community. And I think that's something for us to be aware of and think of. Second, I think the last slide here before discussion and questions and so forth. This was an opinion piece, if you will. I think there are some open challenges for the research community here. One is whether these anecdotes that I presented about language design and language design needs are actually borne out in practice. And I've talked to a great many people about this, and I get, generally I do get agreement on this, but general agreement, I think, is not sufficiently academically rigorous to actually say that that is the case. I would propose that the community, the research community, needs proper user studies here. And we may borrow some knowledge from the information systems field and the informatics people who are more knowledgeable typically than computer scientists about dealing with people and people issues. But if I may be, again, somewhat stereotyping, but a lot of computer science evaluation of software is about grabbing whatever PhD or master students you have around and having them do the system usability scale. And that's not really sufficient. I think something larger and more substantial would be actually needed to evaluate whether what I'm saying here makes sense. My intuition is that it does. I think reuse challenges here, we do need to look at these patterns and the foundational ontologies and their usability by others than their creators. And here we may need to not just keep pumping out new contributions in this space, but actually take a step back and refactor, refine, and think over what we have and how much of it is useful and how to present that usefulness in a way that makes sense. I used to think that an online portal and online accessible context was the obvious choice. And now I'm leaning more towards actually, as proven by others well before me, books as being a good venue for, or a good vehicle for such communication. The Gang of Four book and the Analysis Patterns book and et cetera, they strike the right balance and the right complexity for a lot of reusability. And I think something for the ontology reuse community to think more about as well. And then we have the tooling side of thing where there's two challenges, I'd say. One is the cost of building the kind of things that I'm proposing that we need to build, because that is, again, almost, that's a commercial enterprise almost. And then once it's built, well, then you get into maintenance and maintainability and long-term longevity aspect of it. You know, grants run out and you then go and do something else in the academic community, or you do some, you apply for new grants to do something else. And that's not something that works if we want to build the community resource that lives over time and that breeds trust in the community among people who need to or want to adopt these technologies. I think that's the last I had to say. I think also this entire talk was very much driven by the data integration need. I acknowledge that if you are a semantic modeling person dealing with ontologies for deep reasoning or other interesting challenges, you know, some of this may be off-putting to you. And in that case, I think also lesson learned here may be that perhaps these two communities should not try to share the word ontology and the tools for ontologies, but perhaps we need to face that they are partially disjoint in terms of what they intend to do and why, and suitable tools for doing it. And that is it for me. Thank you very much.
Well, thank you very much. This was a very thoughtful presentation. So we do have some time for questions and comments. I hope that our friends from the Obo Foundry who have presented things on methods and tools and so forth will have an opportunity to ask a question. There are about 16 people on our other chat, and people there can raise their hand if they have a question. I note that Chris Kinderman asked what I thought was an interesting question there. I'll just read that, and maybe if Chris wants to speak up. He says, but aren't diagrams also ambiguous? Just looking at a diagram doesn't necessarily provide me with enough information to know exactly what is meant by the diagram. Coming back to the first example, give an edge between two entities. What does the edge mean? So maybe you have a response to that, and maybe Chris has more to say.
Absolutely. Yeah, that's a great comment, of course, certainly, which is why I think that, you know, the older I get, or the more experienced I get, the more I realize that people who've gone before me have done great things. And looking at how design patterns have been communicated in the past and how designs have been communicated in the past, you would typically accompany those diagrams by written descriptions that describe what they're actually about. So some sort of in-between balance there might work, I guess. But in the use case when you are in the conference room with domain experts trying to understand their domain and trying to help them construct a model, which is a very common use case, that is something that you can add in your meeting notes or on side notes or whatnot, the specifications that help you to specify more clearly what those graphical notations specifically mean. It has never been helpful for me to already at that stage start talking about OWL semantics or shackle semantics. Either you can add those as notes for further specification as you proceed, or you can typically leave them out and come back to people when you need to clarify that en route. But yeah, definitely, diagrams are not freestanding and not sufficient in and of their own.
You made a big point about the need for tools that are transparent enough for people to learn quickly and be effective with. Some people have talked about conceptual modeling tools as being one of the front ends that needs to be. Do you have anything to say about those types of tools? You did mention Neo4j.
Yeah, I haven't used tools explicitly for conceptual modeling that much, aside from things like dragging and dropping boxes on PowerPoint or what have you. But architecture space where people do that kind of thing, and I'm not very knowledgeable about that. That said, let's see. There was a vision once, as I understand, before my time, about generating code from, you'd start with your diagrams and you do them in UML and you'd go all the way to code generation and all of that. And I think that's still sort of a beautiful vision, even though it's not being done very much. But I think it is clear that in order to do that, we are not yet at the fidelity of matching, again, between the diagrams and the formal representations in such a way that that is an automated process that can be done. There's so much ambiguity in there. I'm sure high quality conceptual modeling tools with sufficient sufficient glyphs and sufficient support for nesting and hiding away complexity and so forth can be useful. Sort of tangential is whenever I've done modeling of this nature with people, what typically cognitively seems to work in terms of size is what you'll fit on a medium-sized whiteboard. Not a small whiteboard, not a huge wall covering one, medium-sized whiteboard. That's about the right complexity for many modeling challenges. Or that may be a question of chicken and egg there. What's sort of, is it because that's the size of whiteboard that people are used to, or is it because that's what people's minds are most capable of dealing with? I don't know how I got into that. Sorry, got a bit tangential there, but I guess what I'm getting at is if you're doing conceptual modeling, some sort of nesting away of hiding away of complexity to get to a sufficient size. I think the size bit there is important for reuse to get to a reasonable size.
Very human factors approach. Yeah. If I might just, before turning it over to the other people with their hands up and questions, we had a comment and sort of a question last week with Kogan's presentation, which was recorded, which was the question about how do you, and Kogan, for example, view the work of the Oboe Foundry? There's anything to leverage there? Any tools to comment on? We were just looking for an idea about cross-fertilization and possibility of eventually some synthesis between that community and other communities.
Yeah, I'm going to have to display a stunning ignorance here of actually the contributions there, because I haven't tracked that much at all over time. That being said, it seems to me that the design pattern community that I have been part of for an ontology engineering in the semantic web sense of the word has been sort of, what's the right word to use? A little bit inbred, a little bit sort of small and introspective. And definitely if it would be unreasonable to assume that there aren't great strides being made in other communities that could cross-fertilize and bring value for sure. But I don't know enough about Obo Foundry or the work ongoing there. So you'll have to enlighten me on that.
They may speak up. So Ravi has had his hand up and he has maybe half a dozen comments and questions in the chat, the chat, but maybe one or two can start things off here.
I think you're muted. You're muted.
Ravi.
Yes, sorry, I was on mute. Thank you, Gary. You asked very good questions, as you always do. And I have questions other than what I put on the chat, because Karl, you can kindly access those as Gary or others will put those questions in front of you for later answering. What you bring out are two important things: a digital twin language, which is different. And only comment there I have is that it's not exactly twinning, but on the right side, I see higher level constructs like patterns or the definitions. And on the left side, I see their instantiations. So that's one comment, if I have understood it correctly or not. But the normal meaning of digital twin is more or less mirroring capability. So that is one thing I want you to comment on. The second is very important presentation you have brought is, how do we understand a visualization or a diagram? When will we standardize on the visualization in the same sense that we standardized conceptual data modeling or relational data modeling in RDBMSs? They were pretty mature. And I understand your comments on UML2 and process diagrams and enterprise architecture, where I spent 10, 15 years. So that's very valuable comment. These are a couple of high-level things, and I'll stop now.
So in terms of, I'll just quickly touch on the digital twin thing first there. So just to clarify, I don't think the point of bringing up that language was to bring the discussion to a digital twin space, but rather to say that that level of language constructs and that level of semantics is useful in many contexts, I believe, not necessarily just the digital twin space, but it is a nice in-between level between developers and ontologists, if you will. That being said, when it comes to the digital twin space, there's a lot of ambiguity in that space as well, which I've worked in. So are we talking about complete twinning of everything? Are we trying to build a model with as high fidelity vis-a-vis the real world as possible, or is there some degree of abstraction? And if you're talking about the former, you'd go all the way into, your CAD drawings and your actual physical behavior of the device and trying to simulate that. Whereas if you're talking about the latter, then we're more on the space of data abstraction, data integration, data analysis, getting signals from noise kind of thing, abstracting away and possibly building a knowledge graph about the building that doesn't represent necessarily a physical building, but what I can do with the building, for instance, or the machine or whatever, the boat, whatever it may be. I think those definitions are equally valuable. I think the jury's still out on what's going to become the industry standard definition there. And what I've mostly worked with is the abstracted view, because that is, in most cases that I've been in, what brings value. I have not been in the simulation space. Let's see what else we were talking about. Yeah, about the standardization of glyphs and your modeling languages. Yes, I think that's something that would benefit the ontology engineering community if there was a clearer standardization of those things. And I think work in that direction would be most valuable. However, as has been pointed out previously in this discussion, it's not necessarily the case that there is a one-to-one mapping between graph representation and what we want to logically express. And so there, I foresee such a standardization community, standardization group, having quite a lot of work and quite a lot of vigorous debate in order to achieve consensus on these things. But at the end of the day, yes, I think that would be very valuable to have and to clarify. And I think Kogan and Pascal Hitzler also, and people with them have worked in this space a little bit more than I have in trying to map what are the possible axioms that can map to these simple graphical constructs. And I think there was a list of like 17 or something, or a substantial number of logic axioms that could be derived from the simple node edge node. So yeah, clarification on that would definitely, a standardization of that would definitely be beneficial, as long as it's not a straitjacket for doing interesting things. There's a trade-off there.
Karl, don't we have to go one level above just simple node edge business to multiple relationships, the strength of relationships, as well as uncertainties in the relationships, for us to improve our notion of ontology itself?
Yeah, so and when it comes to uncertainty, that touches on also the contextualization bit. Do we want to be able to express that nodes or that edges have certain threshold values or certain validity constraints or certain confidences or uncertainties and so forth? And as long as the underlying language does not natively support that, then it becomes difficult to represent that, I think, graphically, unless you really abstract things. But definitely something the community would have use of, regardless of, I think, whether it is in graphical format or not. So I'm dropping my train of thought here a little bit. There was, you had another point before then that I also wanted to address, but I forgot. Sorry. What is
mostly on visualization.
Yeah, oh yeah, there was something yeah, about other features above just node edge node. I think something which is very common is taxonomies, and not necessarily taxonomies in the subclass of sense only, but parthood taxonomies or hierarchies in the general sense. I think being able to express in ontology language that these concepts or this relationship is intended to be used for a hierarchy construction, and consequently there are some constraints, like you typically would not want loops in that. You would want a tree structure in those relationships when it's implemented. And you may even want to define a single parent tree hierarchy or whatever. These are very common scenarios in the real world. And if there were ontological primitives that supported that, either in the languages or in the graphical modeling or in both, I think that would be commonly used. So there are a couple of such things. Okay. I think collections also.
Thank you so much. Thank you, Karl. Yeah. Very good.
Edith Kogan is here. He had a presentation last week, recorded presentation. He may have other things to say. I saw that commodity was on your list of activities, and certainly as Kogan is, and so that might represent another tool that Kogan might want to say a few words about.
In what sense? Because anything that Karl would have said would have covered it, because we co-developed it.
Question about relationships with the Obo Foundry community and what you think of it, and what might be a path to some joint work or some coming together on some of these things. Any comments on that?
Not really, mostly because how closely we can work together was only very recently revealed is maybe the wrong word. Made apparent, I guess, to me. So I had a call with Nico a few weeks ago, and there's some very clear connections to the sort of template-based instantiation that we do, to the sort of DOS-P process, and the sort of Otter templates process of you have a pattern, and then you just run a tool that kind of gives you a lot of the pattern stuff, and then you kind of tweak it to your own use case, your own needs, or if not your own use case, then you're adding something new to the ontology. So like adding a new type of protein, but all of the rest of the stuff is still protein stuff. You get all of that structure back. That's probably the most interesting overlap between the two methodologies right now, because it's pretty easily actionable from a tooling perspective. But in the other hand, looking at OboFoundry from a formal perspective and taking a look at how you integrate two ontologies, one where you have a pretty sound upper ontology and then another ontology that doesn't use it, that's still a little bit of an open question, I think, on how to do a proper integration or a proper alignment between those two different types of paradigms.
We are at the hour. I don't know if there's any other questions. There are things in the chat that can be looked at over time, and that they will be posted. We do communicate at the end, and so this issue about how to come together and share things and tools and so forth could be something that might be a little bit more addressed in our communique. But I noted from the little I know about some of this, the OboFoundry has something called dead simple patterns. And when Karl was talking about the proper sizes of things, I suspect that they may be too simple, and there might be some interesting to sort of try to fill them out into what Karl would consider a useful size. So that might be something to think about for the future. James, did you want to say something?
Yeah, I just put a comment in the chat. I mean, one of the goals of the Summit series was to try and connect these communities that aren't necessarily all that connected. I mean, I've been working in Obo for a decade, building semantic web tools with OWL and RDF, and I don't talk very much in the semantic web community. I've been lurking on Ontology for a long time, but I haven't really participated in these summits before now. And I just wanted to mention that, I mean, there's tools such as LinkML, where we are actively struggling with some of the problems that Karl is talking about between like OWL and graphy knowledge graph representations, kind of tools for converting between those kinds of things, and also connecting to tables that users love, which we didn't present in the last 5 weeks. And maybe that's a bit unfortunate. The stuff we presented in the last 5 weeks was very much focused on how we build ontologies at scale in the open with hundreds of scientists on GitHub, and do like continuous integration testing and whatever, integration and reporting and all those kinds of things, which don't seem to be problems that Karl has or Kogan has, or at least they haven't been speaking to those problems. And so maybe that's a bit of a disconnect that we can try and bridge in the coming weeks.
So Chris Mungle unmuted, so perhaps you have something to say.
I think James pretty much covered it. Yeah. So yeah, I think just coming to that perspective, I think has been like incredibly valuable, I think, so far from these workshops. Yeah.
Yeah,
I
agree.
have to head to another call now. Yeah. But thank you, Karl. That was great.
Yes, thank you, Karl. And thanks, Kogan, for the call last week, even though you couldn't make it in person, recording in advance and getting us. We really appreciate that.
I guess we can wrap up. Karl, again, thanks for everybody. This was a very thoughtful presentation. I think there's a lot to think about here and follow up on. And hopefully some of it will be represented in our communique. And I just wanted to mention again, next week we have sort of a dual type of event because Nico has identified that there's a Wikidata presentation on Tuesday at 11 Eastern time that they had organized. We were trying to organize one for our session on Wednesday. So we are going to sort of try to piggyback on theirs, listen in, and perhaps next Wednesday we may just have a little bit more of a discussion on Wikidata or other topics, and it won't be a formal presentation. So Ken, do you have any other items that people should be aware of as part of the summit?
No, everything's going so well.
Okay. Again, thank you, Karl. Thanks for doing this. It was very informative.
Right. See you.
We'll look forward to you in the future.
Thank you.
follow up.